Locomule here. Welcome to my tutorial on coding a sprite for movement and collisions. There are many blocks used to move sprites. This move block moves the sprite 10 pixels every time I click it. A sprite's location is represented by its X and Y values. As a sprite moves right, its X value increases. Changing the block values from 10 to 50 causes the sprite to move 50 pixels instead of 10. Let's create a world for our cat sprite to move around in. A sprite located in the middle of the screen is at 0x and 0y. This go to block puts our sprite there. These change X blocks move a sprite right or left. Change Y blocks will move a sprite up or down. Let's drop the sprite to its standing location on the ground. Our default go to block now contains the sprite's new Y value. I'll get rid of the extra blocks and use the go to block to reset the cat's location when the project is run. Now we can build a script to accept player input and move the sprite accordingly. A little bit of trial and error and we have it. The right and left arrow keys now move the sprite right and left. But the cat walks backwards when moving left. Let's fix that. Scratch sprites can point in 360 degrees. Direction 90 points the sprite right while negative 90 points left. But our cat is spinning in a circle. In Scratch, direction 180 is down and direction 0 is up. We can fix our rotation problem with a set rotation block. Scratch has 3 styles of rotation. We want left, right. With our rotation style corrected, we can add point and direction blocks. Now our cat always faces the direction it is moving. Let's break our movement script into separate pieces using custom blocks set to run fast. We'll use one custom block for X movements and another for Y movements. We can recycle the default variable by renaming it Y velocity. Let's see how we can use it to move our cat sprite. By constantly setting the sprite's Y position to the Y variable, then changing the variable's value, we can simulate a jump. Hey, we are onto something. Let's change the script set Y block to a change Y block and stick our variable into it. If our variable has a positive value, the sprite moves upwards. A negative value moves the sprite down. If the variable's value is 0, the sprite stops moving completely. The further the variable's value from 0, the faster it moves. Let's use all this knowledge to build our jump script. Now our cat can run and jump, but there is no gravity to pull it back down. No problem. Our gravity code operates by detecting the sprite's vertical movement. A positive Y velocity value means the cat is moving up. We can use simple math to slow it down. Testing our script, we see that it slows the cat's ascent until its Y velocity drops below 1, just like it is supposed to. At the top of the cat's jump, Y velocity must become a negative value for the cat to fall. Now the cat falls, but we only drew a visual ground. There is no collision layer to stop our cat. We can remedy this by adding a simple rectangle inside a new sprite set at our preferred ground collision level. Adding a touching sensing block allows us to reset our sprite's Y velocity to 0 when it touches our collision layer. Yay! Now the cat falls back to the ground. Let's hide our ground collision layer at startup. The player doesn't need to see it. Sprites do not detect collisions with hidden objects, so we set our collision layer sprite to a ghost value of 100. Now our falling cat lands on the collision layer. I'll reset its starting Y position to match its current value so it starts on the ground. We only want the player to be able to jump when the cat is on the ground and its Y velocity equals 0. Now I have a problem, the cat won't jump. The last part of our script resets Y velocity to 0 before it leaves the ground. Rearranging the script creates a new problem. A quick fix is to move the sprite up 1 pixel when jumping so it isn't touching the collision layer at the end of our script. Now we can finish our gravity script with code to speed the cat's fall. Hey, look at us go. We are running and jumping. We can jump higher by doubling the jump velocity. But something odd is happening. The cat hesitates before jumping. Let's unghost the collision layer to see what is going wrong. Aha! When the cat falls, it is moving so fast that it is sinking into the collision layer. We have to hold the jump button down to get the cat to jump rather than just tapping the button. We can fix this by altering the ground sensing portion of our script. A custom block set to run fast will complete all its actions before updating the screen. We can exploit this feature. Now when a cat hits the ground, it moves up to just above the ground. Testing shows that our script now works. Let's add a walking animation to our cat. Nice. But the animation seems to run a little bit too fast. We can use a new variable and Scratch's timer to regulate its speed. We can try various values and tweak in a speed that appears visually correct. And just like that, both our script and this tutorial are done. Please like and follow me, Locomule, for more cool stuff.